In cryptography, encryption is the process of encoding messages or information in such a way that only authorized parties can read it. Encryption does not of itself prevent interception, but denies the message content to the interceptor. In an encryption scheme, the message or information, referred to as plaintext, is encrypted using an encryption algorithm, generating ciphertext that can only be read if decrypted. For technical reasons, an encryption scheme usually uses a pseudo-random encryption key generated by an algorithm. It is in principle possible to decrypt the message without possessing the key, but, for a well-designed encryption scheme, large computational resources and skill are required. An authorized recipient can easily decrypt the message with the key, provided by the originator to recipients but not to unauthorized interceptors. Kinds of encryption: symmetric key encryption. In symmetric key schemes, the encryption and decryption keys are the same. Thus communicating parties must have the same key before they can achieve secret communication. Public key encryption. In public key encryption schemes, the encryption key is published for anyone to use and encrypt messages. However, only the receiving party has access to the decryption key that enables messages to be read. Public key encryption was first described in a secret document in 1973. Before then all encryption schemes were symmetric key. A publicly available public key encryption application called Pretty Good Privacy was written in 1991 by Phil Zimmermann, and distributed free of charge with source code. It was purchased by Symantec in 2010. Uses of encryption. Encryption has long been used by militaries and governments to facilitate secret communication. It is now commonly used in protecting information within many kinds of civilian systems. For example, the Computer Security Institute reported that in 2007, 71% of companies surveyed utilized encryption for some of their data in transit, and 53% utilized encryption for some of their data in storage. Encryption can be used to protect data at rest, such as files on computers and storage devices. In recent years there have been numerous reports of confidential data such as customers' personal records being exposed through loss or theft of laptops or backup drives. Encrypting such files at rest helps protect them should physical security measures fail. Digital rights management systems, which prevent unauthorized use or reproduction of copyrighted material and protect software against reverse engineering, is another somewhat different example of using encryption on data at rest. Encryption is also used to protect data in transit, for example data being transferred via networks, mobile telephones, wireless microphones, wireless intercom systems, Bluetooth devices and bank automatic teller machines. There have been numerous reports of data in transit being intercepted in recent years. Encrypting data in transit also helps to secure it as it is often difficult to physically secure all access to networks. Message verification. Encryption, by itself, can protect the confidentiality of messages, but other techniques are still needed to protect the integrity and authenticity of a message. For example, verification of a message authentication code or a digital signature. Standards for cryptographic software and hardware to perform encryption are widely available, but successfully using encryption to ensure security may be a challenging problem. A single slip-up in system design or execution can allow successful attacks. Sometimes an adversary can obtain unencrypted information without directly undoing the encryption. See, for example, traffic analysis, Tempest, or Trojan horse. Digital signature and encryption must be applied to the ciphertext when it is created to avoid tampering. Otherwise any node between the sender and the encryption agent could potentially tamper with it. Encrypting at the time of creation is only secure if the encryption device itself has not been tampered with. See also: substitution cipher, rotor cipher machines, brute force attack, cold boot attack, export of cryptography, Cyberspace Electronic Security Act, disk encryption, key management, physical layer encryption. References. Further reading. External links.